Hey guys, it's Ostrus. Welcome back. Today we're going to be training a LoRA in AI Toolkit with Qwen-Image. Now, if you don't know, Qwen-Image is a new model that just came out. I personally think it's the best text-to-image model that's out there right now, and it's completely Apache 2.0 licensed, which means you can use it for anything you want. It's huge. It's 20 billion parameter, but they're using their own text encoder. So if you look over here on Qwen, for the text encoder, they're using Qwen 2.5 video language. So this is a model that's actually trained on images to decipher what's in an image, kind of like a image to text. Since they're using it as a text encoder, it's an LLM built on Qwen 2.5. That way, when you say stuff like dog, cat, whatever it is, it doesn't just have a textual representation of these things. It actually understands what a dog looks like. So its embeddings that are being embedded into the model are more accurate as opposed to something like T5, which is used in Flux. In fact, most of the new modern models use T5. It's only trained on text. So it's like an encoder decoder for text. But since they're using this, it will actually have better alignment on the embedding space for images. So it should be able to handle all that better, including the way text looks, the hair color, everything like that. So just that text encoder alone is super exciting. For the VEI, they're actually using the WAN VEI from 2.1, not the 2.2 VEI that just came out. But supposedly they fine-tuned it. Haven't verified this. But so it's an actual video model VEI, but it works really good for just images. And if they fine-tuned it to be better at images, even better. But one thing I like about this VEI I've noticed is things are less artifacty. Models trained on it. If you look at Flux in the fine image, like in the fine detail, it seems like it has a lot of noise artifacts. And Qwen is more smooth, or the WAN VEI is more smooth. So it's just a personal preference. And then the transformer is huge. Look at all these files. I mean, each one of these is enormous. Sorry about your hard drives. So apparently this is like one of the only text-to-image models that can do Chinese characters very well. I mean, I don't know. It's all Chinese to me. It follows prompt comprehension really well. It knows a lot of styles. The one thing I don't like about this model is it doesn't seem to do realism very well. Everything kind of has a plasticky look, and we'll go through that. But when you fine tune it, that should kind of disappear. And I'm sure realistic fine tunes will be out within the next day or two. So keep waiting on that. I'm going to go over to RunPod. Again, you can run this locally. I'm just going to do it for ease of use for the video. I'm going to do it on a 5090. So I just added a new feature that allows you to unload the text encoder. Without that, we cannot train this on a 5090, but that's what we're going to use today. So you can do this locally. This is a consumer grade GPU. Although it's the latest and greatest, it currently won't run on 24 gigs. I'm still working on making that happen. Go to change template, go to AI Toolkit, Ostrus, edit the template. I do this in every video, and I say that I do this in every video. So this is the password when you first get on, your token or whatever. AI Toolkit auth, you can put your password here. If you don't do that, the password's just password. Super secure. Let's deploy it on demand and get started. The pod's ready. Let's open it. Click. Connect. HTTP service. Password. All right, we're going to load up our data set. For the data set, I'm going to use my musician character that I've been training. It's a custom character that I've been making by merging together a bunch of LoRAs that I custom trained to make my own person. Identity is pretty good, but they're not absolutely perfect. But it's going to be a good test. So we click New Data Set, Musician, Add Images, and I'm going to just drag over all of my new images. So I already captioned these, and that's another thing you guys can do here. If you have text files that match, you can drag those in here and it'll load them up as captions. You can see all the captions are here. So one thing I've been doing is we've been doing it where it just says woman, because that works really good for a lot of models. So you can just train that every time it sees a woman, this is what a woman looks like. Or every time it sees a man, this is what a man looks like. And that works. In those instances, what we're doing is we're training the model that everything in the image, from the clothes they're wearing to their hairstyle to the style of the image, all of that is part of this person's essence, and all women's essence will be this person. We're going to try something a little differently today. Oh, I forgot to caption this one. But yeah, we're going to try something a little differently today. What we're going to do is we're putting TOK woman. So TOK woman. And the reason we want to do this is just to give it just a special identifier. It works if you're using differential output preservation, stuff like that. It works really good. But this will just be, so now we have a trigger word for the woman. Another thing we're doing is we're actually captioning it. So here I have like close up, wearing a white t-shirt, sunset in the background, wearing a red shirt in a field, etc. I'm going to go ahead and caption this one since this one's missing. Let's talk about captioning. How I like to caption, because I get this question a lot, to caption it how you would type to get this image, right? When you train this, what do you want to do to get this image? I'm missing another caption. Okay, let's make sure we get them all captioned this time. All right. So if I want to generate this image with my trained character, this is what I would type. This may not be how you like to caption. Some people, if they're typing prompts into an image generator, they want to do like quick commas, such as like woman, comma, hair, comma, red shirt, comma. Other people want to do full sentences, such as generate me an image with, whatever it is, however you caption or your target audience captions for. Caption it like that. Another important thing, anything that's TOK woman, that's her name, TOK woman now, anything that's her identity, you leave that out. So we want the red lipstick to be a part of her identity. If you don't want that to be part of the identity, where it's going to generate that every single time, then put it in here. Wearing red lipstick in every single one of these, or any one that they have red lipstick. So anything you caption is not their identity. For their identity, all of that, everything about her facial features, we don't mention the button nose or white teeth or eye color, hair color, anything like that, because that's all crammed into our trigger word. And that's what we're training the model to learn. So that's what I find works best. And again, if you don't want to go through all the captioning, you can just put whatever trigger word you want for all of these and leave it at that, and you'll be fine. But we're going to try one, full captions. Let's pop over to new job. Let's adjust this name. We're going to use Qwen Musician. Okay, we cannot do a trigger word. The reason why is we're going to use this new feature, cache text embeddings. And if you read through this, this is experimental. I just released this yesterday from when I'm recording this video. So what this thing's going to do is it's going to go through and it's going to unload the transformer, and it's only going to keep the text encoder active. And it's going to go through the entire data set, and it's going to cache every single caption to the disk. So anything fancy like doing trigger words or caption dropout or any kind of shuffling, that's not going to work with this, because it's all going to be cached based on the captions we actually have on the image. So don't do a trigger word. If you try, it's going to throw an error. Just letting you know so you can save the time. We're going to come and do, where is it? Qwen-Image. So in the text encoder, we're going to leave this float 8. That's fine because we're going to unload it anyway. But for the transformer, for doing 32 gigs of VRAM, this will not work at float 8. So we can actually, instead of doing 8-bit, we can come to about 6-bit. I did test it on 4, and 4 you get a lot of degradation. 6-bit's actually not bad. So we can do it at 6-bit, and this will fit for training at 1024, and we can also sample at 1024 at 6-bit. So that's good, at least if we drop the rank. So we're going to drop the rank to 16, not just to save on VRAM, but also keep in mind, this model is 20 billion parameters. I mean, you compare that to even like Flux, which is only 12 billion parameters. This is almost twice as big as Flux, not quite, but your LoRa's are going to be twice as big as well. So we don't need a 500 megabyte LoRa to capture a character. So instead of 32, we're going to drop this to 16 General rule of thumb, the bigger the model is, the smaller your LoRA needs to be. Going back to Stable Diffusion 1.5, you really needed larger LoRas to really store more data. So 16 is going to be fine. We're going to leave it at 3,000 steps. I'm going to bump the learning rate up to 2. So 2e-4. If you don't know what the -4 means, just start from the 2 where the decimal point would be. Move it 1, 2, 3, 4, and that's where it is now. So when you see that annotation, 2e-4, that's what it means. People seem to struggle with that. One of the reasons we're going to do this is instead of doing time step weighted, where it's calculated weight on every single time step, we're going to switch this to sigmoid. We're training a character here. If you're doing something else, weighted will be fine. But for a character, what we want it to do is those early high noise time steps. We don't want to train those. Let the model do what it already knows. So build the whole composition of the image of whatever we're prompting. Sigmoid's going to focus on those central time steps, like in the middle where it's partially denoised. So we want it to build the composition, and then we're going to really hammer in how to build our character out on those middle time steps. So this seems to work good. It keeps it where it's more, the model will be more flexible with your character because we don't want it to learn everything in our image, just our character. And then we're going to cache text embeddings. You cannot train this with a text encoder live on the VRAM if you are using a 32 gig GPU. If you don't want to do all the captioning and everything, you can put a trigger word and do unload text encoder. This, if you read here, it works with a trigger word. It won't read any captions, but you have to have a trigger word if you unload. It'll only let you select one or the other. So cache text embeddings, this is if we have captions in our text file. So we're going to leave it on that. With the 6-bit, we can squeeze it on 1024. So we're going to leave it there. You might be able to get by with this same configuration on 24 gigs, but you're going to have to drop your image size. I'm not sure. We're not going over that in this video. For the sampling, we'll leave everything the same except, remember, we have, our word is talk woman. So let's go and change all these out. All right, so we just replaced man, bear, horse, whatever, with talk woman. I also have to change his to her. I do want, okay, so Qwen is amazing at text. Even at the 6-bit model, it's going to be absolutely amazing at text. It blows every other model I've seen out of the water, with the exception of GPT-4o. So I don't want this to just say, this is a sign, which is impressive to keep. You know, this is a test that we see if it's still retaining its knowledge of text, since we don't have any text in our image. But this isn't a very good test because the model's so good at text. So we're going to expand on this. This is a sign, not just any sign, but a sign held by me. My name is Talk Woman. This is being fine-tuned on Ostrus AI Toolkit. I don't know if it's going to be able to get all that. If it does, that'll be super impressive. And if it can maintain it, it's going to be even more impressive. But that's all we got. Recap. We changed talk woman in all these because that's the trigger we're using. You can just use woman. You can just use man. You can use Q, blah, 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 or whatever you want for your trigger word. A lot of opinions on how that works and what's best. We're leaving all this the same. We're going to leave our resolutions the same because we are quantizing 6-bit. Have our musician dataset selected. I bumped the learning rate up to 2e-4. The time step type is, I'm doing it to sigmoid. It's normally weighted. You can leave it at weighted if you want. It's up to you. We are caching the text embeddings. We do not have a trigger word. We're doing Qwen-Image, low VRAM. We changed the transformer to 6-bit. We changed the linear rate to 16. And I'm clicking create job. And I'm clicking play. And we're waiting for samples. All right, it's training. We generated our first samples. So right now, training, it's pulling in about 29.8 gigabytes of VRAM, and that's because we're using int 6. quantization. It's only 6 bits. So we can take a look at our samples. We didn't change in the prompt to red hair, so it's going to give her red hair. But okay, we'll see how that works. The bomb's going off in the background. Man, this is one thing. I like to use the exact same prompts for every single model to see how different models work. And this one is like, generally there may be like an explosion. There may even be some little fire if it shows anything in the background at all. But Qwen is actually, it has a bomb. Like it's almost like an old timey, the little balls with the little fuse sticking out of them. But then there's this other bomb here. So that's really impressive. Another thing is, look at this chessboard. It actually has like the chess pieces. All the pawns are in the front. I mean, it's missing some things, but it has black on one side, white on the other. You don't get this that much with models. That's one reason I like the chess thing, is I know what a chessboard's supposed to look like. This is the closest I've seen, at least on an open source model, in my samples. So that's super impressive. Let's look at the next one. Okay. They definitely trained on ChatGPT 4.0 image. You can tell because, as Coldplay once said, it was all yellow. It has a very GPT 4.0 look. Okay, this one's looking good. She's holding a martini glass. Looks good. Shark jumping out of the water. Oh, it even says cool new for her cool new shirt. It's cool. Oh, okay, this is awesome. So this prompt is woman building a log cabin in the woods. So here's the cool thing. Every single model, and I mean every single one, when I use this prompt, it might have someone standing next to a log cabin. That's it. They're never building the log cabin. They're just next to it. They're actually like building it. There's like pieces of wood. I mean, super impressive. I love this Qwen model. So cool. All right, we have punk rocker. Another very ChatGPT-like image, all orange, but everything's looking good. Anatomy's good. Building a chair. Then we just have on the white background, and then here's our text. Looks very ChatGPT 4.0. So this is a sign, not just any sign. Bit as sign held by me, but a sign. But a sign. My name is Talk Woman. This is being fine-tuned on Ostrich AI Toolkit. It's not perfect, but it is better than any model that's open source that I've ever seen. And this is running at int 6. I'm just blown away with this model. So good. So good. Let's see if that text holds, though. And then we have post-apocalyptic, holding a gun. So you can tell in all these, none of these look like a real image. This one maybe, but even that one, there's not a single one of these images, though, that if someone showed me this, I'd question for a second that if it was AI. So we desperately need a realism fine-tune on this. But even fine-tuning on realistic characters will help. My character is already generated with AI, so it may not give it super realistic qualities, but it'll help. The first training samples are done. Let's make sure we're still on track. Okay, so we start here and we go here. It's looking more GPT 4.0-ish, but it is capturing our character more, definitely. It's getting the red lipstick and everything. That one's doing good too. Starting to go to the trajectory. Nothing's breaking really. Okay, these are all going good. That one's zoomed in quite a bit, but that's fine. We're not going to see a whole lot here. We just want to make sure on the first samples that nothing's like breaking and that it's actually learning. If the learning rate's too low, it won't be doing anything here. So we want to make sure it's going in the right way. We also want to make sure the learning rate's not too high where it's just trashing the model. So right now, it's a nice smooth transition that's happening. Going from there to there. Looking good. Okay, let's check our text on our sign. So it goes from there to there. It's definitely starting to look more like our model. The text is the exact same. I mean, it's moved a little bit, but the text is the exact same. So we haven't broken down the text understanding. Sometimes you'll be surprised that the text understanding seems to get better. even without us having text in the data set. I'm not sure why that is, but it just happens sometimes. And it's all looking good. Okay, well, guys, you know the drill. The training is complete. I love to see training complete up here. You can look at the size of these checkpoints. Remember, we did a 16 dimension or 16 rank LoRA. It's 281 megabytes for that. It is still huge. We're going to go check out the samples, but before we do, I want to remind you the character we're training. Here's the data set. So even though all of these don't have perfect identity, it's close enough. So you can see she has the red lipstick in every single one. She has black hair. Sometimes she has bangs. Sometimes she doesn't. Kind of bluish eyes. So this is our character. So burn her into your memory real quick. And then let's go check out our samples. All right. We'll just scroll all the way down to the bottom and get to the good stuff. So these are the final samples. Step 3000. So this one's prompted for red hair. That's what you would expect. So that's good. It does look like her. So let's go. Okay, yeah, that's dead on accurate. I love it. Let's go up a little bit to see what it was learning. Yeah, looks good. Identity's not perfect there, but close enough, I think. Let's see, that looks good. Remember in our samples, see this is still over contrasted. Some of that's the model, but also since these are all AI generated, they're all super contrasted as well. So real images, you probably wouldn't get that effect as much. It would clean it down. And you can always bump the CFG down some since this model does guidance. So this one, it's pretty good. The hair's not black, but you know, it's a real small image out there. Kind of expect that. That one looks good. Okay, yeah, still looking good. And perfect. All right, this is the important one. Let's see what we have. This is a sign, not just any sign, bit, a sign held by me. My name is Talk Woman. This is being fine-tuned on Ostrus AI Toolkit. Awesome. I remember the bit was wrong, although I think fine-tuned was spelled wrong. Let's go to the initial sample. Yeah, fine-tuned. So it actually improved its spelling. So that's good. It didn't break down. And it looks a lot less ChatGPT-like. We scroll it on down. Perfect. And the identity is great too. And post-apocalyptic. Still kind of has the cartoony look, but that's what the sigmoid time steps will get you because it tries to keep the composition. It tries to keep its knowledge of the image. You're just kind of feeding it in the character in the middle time steps. So I'm happy with this. I think this is a total win. So that, ladies and gentlemen, is how you can fine-tune Qwen-Image on a 5090 with 32 gigs of VRAM, so consumer-grade GPU to train using AI Toolkit. I think Qwen-Image is going to show itself to be the best text-to-image model we have out currently as soon as we can get all the tooling built up around it. I'm doing my part to do that. And if you appreciate that and appreciate my work with AI Toolkit and making these videos, please be sure to like and subscribe. That helps the channel out a lot. And if you really want to support me more, you can head over to ostrus.com/support. You can read up on here of how to help support me financially. I do open source full time, so I don't have a real job. This is what I do. And all of that is made possible by all of these amazing people who currently support me. Companies at the corporate level and individuals that are giving a ton. All of this keeps the lights on around here, keeps the GPUs running, and I appreciate every single one of you. You could be one of these people on the next video. So go sign up here. That's it. I'm Ostrus. I hope that was helpful, and I'll see you guys next time.